Okay, this is our first unit. It is energy and power. The learning goals for this unit, I want you to explain the difference between energy and power. I want you to be able to discuss the different types of energy, to understand the law of conservation of energy, and to solve problems involving kinetic energy. So let's get started with something fun. Explosions. An explosion happens when there's a great deal of stored energy that is suddenly converted into heat, usually within a confined space. Think of a grenade, or the atomic bomb, or simply an asteroid hitting the Earth. The heat is enough to vaporize the material, that means turn it into a gas, and it's a really, really hot gas, so it pushes out. The gas has an enormous amount of pressure. Pressure is like a force over an area. So a large pressure means that there's a great force pushing out on everything. The flying debris then does the damage. Now this is something that might be a little hard to think about, but if I were to put a stick of dynamite in a classroom and let it explode, if you're, I don't know, 10 to 15 feet away from it, you're probably going to be all right. Your eardrums will be hurting, maybe damaged, but your chest and everything will be fine. Now, if I were to encase that dynamite in metal, then we would have a problem. Then you would have a bunch of debris that would, do a lot of damage. So it doesn't really matter what the original form of energy it is. It could be kinetic energy, such as the kinetic energy of an asteroid. It could be chemical energy, like the explosives in dynamite, or TNT. But it's the rapid conversion of this energy into heat that is at the heart of an explosion. So that brings us to a couple topics. First one is energy. Energy is the ability to do work. I don't want to get too involved with math, but I do want to show you some math. Work is a force vector times a displacement vector times cosine of the angle between them. So let's say I have a box and I am applying a force at some sort of angle. Think of a rope tied to it. And this box is being pulled some sort of distance. It would take energy to move that box. And if I were to take these three things, this force, this displacement, and this angle, and put them into this formula, that would calculate for me how much energy it took to move that box. Notice that if theta, if that angle equals 0, cosine of 0 equals 1, so it would just be a force times the displacement. Another definition for energy is anything that can be turned into heat. See lots of spelling errors, I promise. So anything that can be turned into heat. So then, what exactly is heat? Heat is something that's going to raise the temperature of a material. So there you have it, energy and heat. And in many ways, they're kind of the same thing if you think about it. All right, now, the amount of energy. We need to be able to measure how much energy something has. And believe it or not, chocolate chip cookies have more energy than dynamite. And that is really, really weird to think about because we see the destructive effects of dynamite. The only destructive effects of chocolate chip cookies will be on our waistlines. So how is it that a chocolate chip cookie can have more energy than dynamite? It's kind of a paradox. So I'll be presenting a table with several different items along with their energies. So you can kind of get an idea for how much energy different things have. First, I need to talk with you about units. How do we measure energy? What are the different units? The first one's a calorie. And calories can be difficult because we have two types. We have food calories and we have science calories. So typically the calorie is what we use to measure energy in food. So here's where we have to be careful. A food calorie is different than a science calorie. We typically use a capital C for food calorie. And one food calorie equals 1,000 science calories. So if I have a 12-ounce can of Coke, that typically has 150 food calories. So that would be 150,000 science calories. And we'll talk a little later about how a calorie is measured and what a calorie really means. The next unit you might be familiar with is the kilowatt hour. And we use this to measure electrical energy. So the power company will measure how many kilowatt hours your house uses. Typically, 1 kilowatt hour will cost you roughly 10 cents. That changes from year to year. It changes depending on the price of coal. It changes on the weather. It changes on everything. But usually, a kilowatt hour will cost you about 10 cents. So, now notice we have a couple words in here. We see that we have the kilo before the watt. Kilo is a metric prefix. It means 1,000. So we can also have a watt hour. 1 watt hour is roughly 1 food calorie. That's usually a close approximation. So 1 kilowatt hour is roughly 1,000 food calories. So if you could turn a McDonald's Big Mac it's just under 1,000 calories. It's pretty close. So if you could turn a Big Mac into electricity, 1 Big Mac would give you approximately 1 kilowatt hour of electricity. All right, third unit you probably have heard of, and that is the joule. And this is the preferred unit of energy in physics. So, 1 food calorie is 4,200 joules. 1 kilowatt hour is 3,600,000 joules. Now, I would really prefer to use a metric prefix. So since I see million there, the prefix mega means million. So I would say this is 3.6 megajoules. And mega is used with a capital M. All right, so let's take a look at a table of some various objects. Now we have to make sure something about them is all the same. So what this is will be energy per gram. So remember, gram is a unit of mass. We can measure out a gram. So let's take a look at our first one here. Our object, the first one is a bullet. And so if I had a bullet that had a mass of 1 gram, and if it were traveling at 1,000 feet per second, well, that means that it would have kinetic energy. And calorie, which remember 1 calorie is roughly 1 watt hour, it would have 0.01 calories. So really not a lot of energy if you think about it. I mean, a typical meal is going to be 500 to 700 calories. That gives it roughly 40 joules. And then if I were to compare that to TNT, it would be 0.015 the amount of TNT. Right, car batteries. This is kind of difficult to think about, but if I could have just 1 gram of a car battery, it would have 0.03 calories. So it's about 125 joules. And compared to dynamite, 0.05. So again, not even close to what dynamite is. A laptop battery, these are a little more powerful. They're lithium-ion batteries. 0.1 calorie if I had 1 gram of a laptop battery. 400 joules, 0.15 of a gram of dynamite. A flashlight battery, this is an alkaline battery. In fact, let me go and put this. So this is an alkaline, this is a lithium ion, and car batteries, lead acid. Okay, so for a flashlight battery, a little more. So 0.15 calories, so that's around 600 joules, and that would be 0.23 of dynamite. Now dynamite itself, if I had 1 gram of dynamite, 0.65 calories, or roughly 2,700 joules. So if I were to compare that to dynamite, obviously 1 gram of dynamite would be 1 gram of dynamite. Okay, now dynamite has changed over the years. We have some modern dynamite. Instead of TNT, it's PETN. So this, 1 gram of this would have 1 calorie. So notice it's a little more explosive. It has more energy. 4,200 joules. And 1.6. So now we finally crossed that threshold. We've got something that's worth more than TNT. A chocolate chip cookie. 1 gram of chocolate chip cookie has 5 calories. So that's 21,000 joules. And 1 gram of chocolate chip cookie has 8 times more energy than 1 gram of TNT. That is a lot. Coal has 6 calories, 1 gram of coal, 27,000 joules, and it has 10 times the amount of energy as 1 gram of TNT. Butter, yummy butter. 1 gram of butter has 7 calories, so that's 29,000 joules. And 1 gram of butter has 11 times the energy as 1 gram of TNT. Ethanol, go down here a little bit, has 6 calories, so 1 gram of ethanol has 6 calories. So it's going to look the same as the coal. So notice that between coal and ethanol, we get the same amount of energy. So that's something to think about. Gasoline, 1 gram of gasoline has 10 calories. It's 42,000 joules, and that means gasoline has 15 times more energy than 1 gram of TNT. Natural gas, so 1 gram of natural gas has 20 times more energy than 1 gram of TNT. Hydrogen, 1 gram of hydrogen has 26 calories. That's quite a lot. 110,000 joules. So 1 gram of hydrogen is 40 times more energy than 1 gram of TNT. An asteroid. Now, this asteroid, let's say it's moving at 30 kilometers per second. We have to say that because, an asteroid by itself has no energy. We'll discuss it later, but a moving asteroid has kinetic energy. So really what we're doing is we're comparing kinetic energy. So if I had an asteroid that had a mass of 1 gram, so that's a really small asteroid, moving at 30 kilometers per second, it would have the equivalent of 100 calories, so that's 450,000 joules. and it would have 165 times the energy as a 1 gram of dynamite. Uranium-235, this is what we use to power nuclear power plants and atomic bombs. 1 gram of uranium-235 has 20 million calories. That means it has 82 billion joules of energy, and it has 30 million times more energy than 1 gram of TNT. So, when we take a look at this, we can see then that, go back a page here, we can see that, a chocolate chip cookie has even more energy in it than dynamite. So we're going to finish this video here, and we'll come back to it in video 2.